Yeah, thank you for attending, and it's nice to be here. Thanks. Is it you go by Danny? Danny, yeah, okay, Danny. Thank you, Danny, for inviting me, and it's nice to be in Barcelona again. I've been here, a few different times, and it's a nice time of year to be here. So I just wanted to mention a few other things. So I have a colleague here with me, Tomasz, or Thomas Jaskula, if you can just stand up. And Tomas is going to be helping me with teaching my IDDD workshop in the French language. So he'll be working in France, and also he's a native Polish speaker, and so we're going to try to also teach in Poland. So, and I had Tomasz helping me in the workshop this week, so it's great to have him here.
Thank you.
Okay, so you're probably wondering, okay, you can understand the term reactive DDD. You've probably heard of reactive programming, reactive software development, and software that is reactive. But what does it mean, waxes? So when concurrent waxes Fluent? Well, if you know what wax is in English, it means like, if you wax a car, you make it shine, right? You make it glisten. So it seems like we're entering an era where concurrency really matters, and people are getting used to the idea that they need to use a reactive approach to software development to get the scalability, the efficiency, the throughput that they need. But one thing that I see lacking in the reactive community is that the APIs that are available and the way that the toolkits and frameworks are designed don't really lead to very fluent domain models, but what they really tend to do is be more of a technical approach. And frankly, we've been such technical community of software developers over the years that I think that we really need to get back to the basics of software design, where the way that you express your software as fluent models should really matter. I think it should be very important because it makes the software model understandable to normal humans, not just the high-tech people or the maybe smartest 1% of software developers in the world, but business people and those not familiar with technology. So obviously the business people that are leading companies are very smart people, but it doesn't mean that they understand the technology aspects, the very techie type of things. So why don't we make conversation and collaboration work even to the point of understanding the software model? So that is where waxing Fluent, right, or waxes Fluent comes into importance with concurrency. So we're going to talk about both tonight. So where are we in the software industry right now? I think it's pretty obvious to most of us that we experience this kind of result in our software designs. And you might look at a big ball of mud like this with what we might call some God objects and other tangle in the model. And it's just not a great experience to have to work in this environment. And you might say, yeah, design, that doesn't look like design to me. But you know what? Everybody designs software. Whether you're trying to design software explicitly and fluently, or if you're just knocking out code from your keyboard rapidly, we're all doing design work. And so there's no such thing as no design. There's just bad design and effective design. Yeah. So I think that, you know, while this is where we are, we need to do something different. Another place where we are right now is with very inefficient software. Our software over the decades has largely been of a blocking nature, and that means that when I have a client object, this is not a client node and a server node, this is a client object and a server object, so it's an object that provides a service and a client that needs that service. And so when I ask for a service to be performed by the server, what happens to the client? It blocks. It waits until the request has completed, and then when it gets control back with some kind of return value or just a void return, no useful return value, then it can continue operating. So inefficient software because everything is waiting for something else to complete. And we not only experience blocking in behavior, but we experience blocking with our HTTP requests and responses. Okay, we're seeing some solutions to that with some of the web servers available, the web containers and so forth that are offering some asynchronous capabilities, but we also experience a lot of blocking in our databases and just about any kind of operation that we perform. Probably there's a lot higher there's a lot higher probability that your software will block than it will be non-blocking. And we also are using Anemic domain model. You know what I really dislike about this name is that it includes the words domain and model together. Actually, I wish that it was just named Anemic or something, because I don't think it's a domain model at all. And what actually happens is you'll go to conferences and hear people speak about this, and they'll point to a code sample like this, and they say, in the domain model, it's not a domain model. This is an entity in a database, and we've decided not to write a direct SQL query to interact with that database. Instead, we've decided to put the column values into an object and then have something else put that data into a database table, right? A row in a database. So everything here is just annotated as if it's a row in a table, and it's either an identity or it's a column in a table, and that's about as far as our so-called domain models go. So all this results in a lot of bad outcomes, a lot of very negative or inferior outcomes. So I think that this is a big change that we need to make. This is where we need to go in the future. So where are we headed? Well, if we know what is better, a better approach, then we really should take this someplace else. So I think that instead of crowding a bunch of objects into one big ball of mud, we should think about breaking up the concepts of that are often jammed into a single monolith, but really a messy monolith, and instead think about the language drivers. What are the business concepts that we're speaking about as a team? Or are we even speaking about them as a team, right? Do we invest time to collaborate, to have conversation, to express our thoughts in scenarios, to use tools like event storming, to use tools like unit tests or acceptance tests to assert that, with business experts, that we are doing things the way the business thinks about it. So the business has a mental model, and then when we challenge that mental model with, technology, then the mental model changes a bit because we have to take the thoughts of maybe the way the real world works and make them happen in software. So that's always a bit different than what we imagine it would be, in the quote-unquote real world. So, think about dividing software up into boundaries that have language drivers, where a certain set of concepts have a language that we call in domain-driven design the ubiquitous language, and in order for this language to have clear meaning, we draw a boundary around it, and within that boundary, those words, those terms, the verbs, and any kind of description or adjectives and so forth all adhere to a specific meaning within a boundary. And because we have this kind of boundary, and because within a boundary we have very limited concepts that solve a specific kind of business problem, the number of concepts within the boundary tend to be quite limited. So not as usually as limited as a single entity type, but also nowhere near what we face in a big ball of mud. I also think that using reactive, message-driven software is quite important because it allows the sender not to block while the receiver of this message is doing something in its behalf. Instead, what's happening is the thread that the sender was using for the time that it was making a request is now given up, and it's being used by some other, let's say, actor or object in the system, and until this receiver responds with some sort of indication that it's carried out the request that we've made to it, the sender won't need that thread. So there's no blocking involved in this operation, which means that we have much more efficient use of the threads that are available on any given node of a machine. Event-driven is quite important, and if, like we had about 27 people in the IDDD workshop this week, and I have to say that I think that people really get the basic concepts of event-driven software, or even message-driven. So events are a kind of message, let's say, but message-driven in general. But where events are flowing around a system solution to cause ultimate outcomes that we want to have for the business. It also can really bend our minds quite a bit to try to consider a new way of thinking. But what I'm really happy about is at the end of a workshop, you see all these sort of confused looks on people's faces or in their eyes, and they're struggling a bit. But after they struggle for a few hours on a new concept, they have these sort of breakthroughs where they start to understand the asynchronous nature, the concurrency, the parallelism, and also, where although events seem to be going everywhere, they're also explicit, so we know exactly what the event means, why it's happened, and we can react to it. So I think this is sort of where we need to go. And I just wanted to kind of give you an idea of the fact that I'm not new to messaging at all. This broken coffee cup, this is a mug that I got from, or a coffee cup that I got from Microsoft Corporation. This was in about the year 1986. Daniel, by the way, in saying that I have about 35 years experience is just, it's a nice way of saying I'm old. But when you go back to the year 1986 and Microsoft was still, in a partnership with IBM, and they were creating this new operating system called OS2, I was asked to write a book with another author, so we were co-authoring a book about OS2. and it was a programming book, and so we were using all the interprocess communications as they were known at the time, so message queues and semaphores and pipes and so forth that were built into the OS/2 operating system that were pretty novel to most PC users unless you were used to working on Unix, because Unix had these concepts for a few years before OS/2 was created. And so I actually created sort of a messaging system that actually scared Bill Gates. So Microsoft wants me to write this book on OS/2, and so I write this windowing system that actually worked in character mode, because at the time, graphical user interfaces were quite expensive to write, because just the graphics display itself, like a high-resolution graphics display that you needed to really do Windows development at the time, was expensive. And the RAM that you needed in your PC was expensive. And so I had sort of this idea that, well, what if we just did that kind of Microsoft Windowy or OS/2 presentation manager kind of thing, but we'll do it with character mode. And so we can use monochrome displays that are inexpensive and maybe the lower resolution color displays. And it worked just like Microsoft Windows. Asynchronous communications, Windows updating concurrently, in parallel, multi-threaded, multi-process, and then Bill Gates saw it, and he said, shut it down, because it might compete with Presentation Manager. It was only a few months later that Microsoft decided they didn't want to be involved with OS/2 anymore, and so that was kind of the end of OS/2, because IBM could never make it happen. But this was kind of my, with some experience in doing this kind of work in Unix before the year 1986, then, I proved that message sending really works well with software. And so, yeah, it's not really new to me, but I still have the coffee cup to show my efforts. Okay. So, reactive, but what about the language investment that we've made? So there's reactive software development tools and languages that have been available for quite a while, like Erlang, right? Is anyone here using Erlang? And I don't mean have used Erlang or played around with Erlang. Are you shipping code in Erlang? Okay. So, yeah. Why not the rest of you? Seriously. How many here are using Java? How many here are using C#? How many here are, what other languages? Ruby? Few? What other languages? Shout it out. Python. Oh, okay, a lot of Python. Okay. Go. Okay, good. So you have some coroutines, and so you're doing some reactive development there. Though, but we have a big language investment, right? In Java and C# and in .NET, Java platform, Python, whatever our language is, it seems like, adopting a language like Scala may be a pretty big step for us. Maybe not, but maybe it is. So what if we could maintain our investment in the language, the hard-won skills that we have had over the decades with Java, C#, languages like that, and still be reactive, but also have fluent domain models, type safety. Wouldn't that be nice to have reactive development that is type safe, and it's actually testable. You can actually test and assert that your software works correctly. So Reactive DDD is of course multiple bounded contexts. You can think of these bounded contexts as microservices. They're not teeny tiny microservices, but they are small microservices, and we want to have reactive everywhere. So we want reactive within the bounded context. We want reactive between bounded contexts. And so this is, I think, where we need to go. So what does Fluent mean? So if you define a protocol, and this is a protocol in Java, could be C#, but if you define a protocol which is an interface, say that we define a protocol called proposal, and that proposal has behaviors named submit for, deny pricing, verify pricing, and so forth, right? Wouldn't it be nice if you could just tell an object to do this, but the object, you don't block while that object does some operation? So proposals submit for client expectations. Doesn't that just read? I mean, I know it's not Spanish or Catalan, but probably even in English you can appreciate that this reads like you would talk to a business person. A proposal is being submitted for a client that has expectations, right? And so this is what I'm talking about when I say Fluent. This is not giving emphasis to technology, and I mean, we are using technology, but we're also writing or implementing models, you know, just the way that people speak. And even at the technical level, we can still have fluency in our API, such as, you know, asynchronously, we're looking for an actor that's alive in a stage, and when we get that actor asynchronously, then we can dispatch to that actor fluently and then into, right? So now we're saying, after we find this user actor, we're going to send a message to that user actor, and we're going to get some sort of message back from this, or it's possible that the actor wasn't found at all in the stage. It doesn't exist. So what does that mean? Well, if this is handling an HTTP request, then we're going to respond with a response of not found if we didn't find that user. And if we did, we're going to respond with an OK with that user serialized, okay? So in a very compact, expressive way, we both have an API to use that enables us to use parallel, asynchronous, concurrent operations, and yet control the complexity of dealing with that through a very expressive API. That results in something that we understand and have experience with, HTTP, REST, and we're exchanging resources, and in some cases there will be a not found result, and in other cases there will be an OK result. Yeah, so when you look at this, do you imagine that this is reactive? It is reactive because there's a certain protocol that's going on behind the scenes when we actually invoke this submit for operation. What happens? The method invocation itself and the parameters passed to the method are reified into a message that is sent to the actor that is identified by the proposal and delivered asynchronously. And so the client of this expression is not blocking while this operation is taking place, while it's being handled by the actual proposal. And the proposal has the ability to handle the operation asynchronously, non-blocking. There's no synchronization, no locking around, or any volatile kinds of objects. What about type safe? So if we're submitting a proposal with client expectations, look at how fluent we want our client from a client ID and the expectations of a summary, a description, completed by the steps to be performed in this job proposal and the price that we accept. So, but what happens when we're dealing with asynchronous, concurrent parallelism? It introduces some uncertainty. Right? We're turning over part of the control that we like to have with software. I'll keep talking. I hope I'll step up a little bit. Maybe I can project better. And I won't hold this right now. I feel a little silly talking into the mouth. So we're giving up some of the control that we like to have by blocking, right? It gives us that certainty of saying, until this finishes, I don't have to worry about anything else happening. I don't have to wonder, when will this complete? I don't have to wonder what order might some outcomes, how might they complete? And so we give up that level of certainty that blocking gives us. And when that uncertainty scales, right, across multiple bounded contexts in a distributed system, you know, what happens with that? It means that, you know, any other bounded context that may be reacting to the operation that we set in motion by an outgoing domain event from one bounded context may cause any number of results, as in, when will I see any of the three reactions that we're expecting to experience? Will we see only two of them? Will we see only one? Will we see all of them, but will they be quite latent? Well, actually, there's a way to free your mind from this, because we can model the uncertainty right in each domain model. We can make it part of the business process. We can, because we are working in distributed computing, and so we can model it as part of the business understanding. That's why when you model a domain, the model that you're creating is not a real-world realistic model. It's a model that has to work in the environment that you've created, which in our case many times these days is you know, a distributed, uncertain environment. So we're going to actually embrace the fact that we have uncertainty to experience in our solutions, and as we experience those uncertainties, we can model for them and even care for timeouts and sort of what we might think of as a failed process. So, for example, in this model, we have a proposal. So it's a proposal entity, which is the implementation of the proposal protocol. And this proposal entity is an event source entity. Okay? And we have a client with expectations. And when a proposal is submitted, we need results from a pricing context. We need results from a profiles context. We need results from a scheduling context. We don't know if and when any of these will complete, but what we do need to know is, as they complete, how do we disregard knowledge that we've already gained? Like, what if we find out that pricing is verified? Do we want to act on pricing verified again? Do we want to act on you know, some sort of worker in a profile being recommended multiple times because a message was delivered to us multiple times, and so forth? So we can actually model this using a simple concept called a progress, or whatever makes sense to your business. And so while a domain expert or business people may not think of a progress as being part of a job proposal, it's necessary if we want to model the uncertainty and complexity of a distributed computing environment. So we introduce a new concept called a progress, and this manages deduplications and resequencing of notifications and so forth. It's a natural concept that works out in business terms. And it's not just a technical implementation. Okay? So, for example, when a progress says that we have verified, that it's verified for pricing, it's going to answer a new progress that it has verified for pricing. So this is actually a very functional way of doing this. So the progress is what we would call in domain-driven design a value. It's a value type. And and now let's talk about microservices just for a few minutes. Microservices. So, thank you. Test. So if everyone is going microservices, don't we want to go microservices too? Isn't that the tendency, right? We want to kind of get the experience that others are enjoying. I have to say though that depending on how you model your microservices, some describe it as, you know, again the distributed big ball of mud, right? Or trying to debug them becomes not debugging but a murder mystery, you know. So, you know, you may wish for something, but we have to be careful what we wish for sometimes. But so, you know, I have to say this is really what the business wants, right? The business wants money. And the business wants money, but what you want to convince them is they don't really want that. Right? So we've got this really, you know, distributed system of microservices that make money. So let's get some definitions. What is legacy? This is legacy. Okay? You look at it like, ooh, man, that dirty towel, right? That big ball of mud. It's a mess, but this is how the business views it, right? These things have been making money for decades, and we can't just throw them away. Okay? So when you think of legacy software, think of it like that. And you know what else, though? Just because a legacy system is a monolith, or that any application or system is a monolith, doesn't mean that it's a bad thing. Because look at this. This is a monolith, but this is a well-modularized monolith, right? Okay, there are a few things that look a little weird, like a few gigantic objects in here. Wouldn't you just love to refactor a few of these things? But you know what? You can, because you can understand it. It's modularized. And notice that there's loose coupling between the modules in this monolith. And maybe they're even speaking to each other asynchronously through threads. But it's all deployed as one big, you know, thing in a VM organized. So when you hear complaints about monoliths, make sure that you don't just sort of, you know, agree too quickly. If you create a nice modularized monolith, you have a much better chance of succeeding with it and being happy with it than you would, you know, the big ball of mud. Like this. So that's the contrast that I want to feature is when someone says monolith, do they really mean this? Because this is a monolith, big ball of mud monolith, but it's not, you know, the kind of monolith that this is, well-organized, well-modularized monolith. Okay? What is a microservice anyway? Depending on who you ask, it may mean that it's 100 lines of code. That's the definition, right? 400 lines of code maybe. Someone says, 100 is too small, but 400, that's right. What about 1,000? Anybody go for 1,000 lines of code? So imagine that you've got these 100 lines of code microservices. Isn't that unfair? There's only one entity in each of these microservices, but I'm drawing each of those little microservices with one entity as if it's a big ball of mud. Isn't that unfair? No. Because look, they're already coupled to some topics on, you know, you think that you're using Kafka, so you're doing everything correctly, right? And then, you know, what happens over time? you start thinking, oh man, we got these like several dozen microservices, but which ones are dependent on the other microservices? When this happens to this tiny microservice, right? What are the dependencies? How do I reason about this? Can we shut this microservice down? Is it obsolete now? Not sure, right? Not sure. If we shut it down, we might break the whole system, right? So what you have is a distributed big ball of mud. But then you realize, you know what? It only costs $400 a month to keep all those microservices running, each one. So let's just leave them all up forever. We'll never shut anything down. And I am serious. This is a recommendation with the 100 lines of code microservices. And then, what do we get, right? They just keep growing and growing and growing, and 400 times 12 is now 400 times, 500, and then 400 times 1,000. And let's just run the numbers here, right? So we've got a bunch of infrastructure showing up that we weren't expecting because we didn't think this all the way through. Who would ever think that with 2 million lines of code in a complex system, or maybe even 5 million lines of code, that this would all result in an $8 million a month cost for our microservices to keep them all running? That's $96 million a year. And what if it's 5 million? Who here works in a 2 to 5 million lines of code system? Wow, you are blessed. I mean, imagine that you show up one day to the CFO's office and he says, so $240 million a year to keep these 50,000 microservices running? Seriously. I mean, would you keep your job over that? I don't know. So think about bounded context. It's not one of those tiny microservices, but bounded context is also not a big ball of mud. It's not even a monolith, okay? We are purposely breaking up bounded context into smallish microservices, but maybe cut the number of microservices involved in that total solution by, 100 times or something like that. Divide by 100, and it would certainly be a lot easier to reason about and maintain. So this is what we need to do. We need to think about the strategic drivers. We need to make it our goal to stop developing only the ordinary business solutions and go for the distinguishing business solutions, those that have strategic advantage. Which means that we need to tell objects what to do, stop asking them for their state and deciding for them what they should do. So we're going to tell them what to do through rich behaviors, and those behaviors can be implemented in reactive entities, for example. So this client knows how to demonstrate that it relocates. Yes, it sets a value of a postal address. Notice that postal address isn't 12 different string attributes that are being passed in, as arguments, but it's one single concept of postal address. And in addition to setting the postal address, we're also emitting a client relocated event. So now this event can have a positive impact on downstream bounded context, other models that need to know that perhaps we need to ship an item or deliver service to an address, a postal address that is different than the one that we first thought it would be. And did you think that maybe that monolith could be a number of bounded contexts that are well modularized? You can literally use DDD in this fashion. So you have a monolith, but we're modularizing according to bounded context. That's pretty cool, huh? And so reaching from monolith to microservice is much more achievable if we have modularization. Whereas if we don't, right, how in the world do you get there? Well, this is a much more complex thing. It's not something that has always resulted in failure, but it can. So you have to be very careful. And, you know, ask yourself, do we really need to rewrite the system, or should we look for opportunities to use the software that's there? And, you know, if you're still working with COBOL, if your organization's still working with COBOL, I'm going to suggest that it's a really good time to start thinking of alternatives. Because the people working that have COBOL experience are being hired out of retirement for hundreds of dollars per hour to work on these systems, and these people just are not going to live forever. So, give that some thought. And then, you know, how do we deal with the big ball of mud? How do we get it to a modularized condition so that we can do this? So if you're going to eat an elephant, how do you eat an elephant? You know, one bite at a time, right? And, which means that if you use a value-driven approach, that when there's a request to make a change in this software, we can start sort of eating the elephant by putting some tests around things, putting some modules around things, as in packaging or namespaces and the like. And little by little, we can achieve some modularization in this, and over time it may be possible to, you know, eat this elephant. We can reach an event-driven approach if we strangle the big ball of mud. So this is a slightly different approach where we start picking off pieces of the big ball of mud, and maybe, you know, extract some of the parts of the big ball of mud and move them into a bounded context microservice. But how do we do that? So one approach is we set triggers in the database. We create triggers in the database that when tables have inserts or updates in them, we can trigger to create events that are put onto a topic, and when the event is seen by this microservice, this bounded context, some operation is performed here that compensates with the big ball of mud, and then it's also going to emit a domain event that will be put onto a topic that will be read and consumed by the big ball of mud, and we're going to have compensation then from when the user uses this bounded context, because you know what happens is even when we start breaking up these big balls of mud, most of the user interface is still pointed here, right? So we have to make sure that any data that ends up here is reflected over here. And so we can use domain events to create this sort of you know, dependency updates eventually across bounded context. Now, this is difficult. I've done this, but it works. You can accomplish this. The really tough thing is that usually when you have this kind of big ball of mud situation, the database is also a wreck. You know, I mean, right? I mean, you've seen it. The tables are like, you can't believe anybody had any idea that this was third normal form. So what can you do about that? Well, it can be hard to figure out where our triggers should go, so we can use tools like Dependencies, which is an open source tool that is basically a commit log tailer, right? The commit log tailer says we're going to see any new commits to the database, and as we see those new commits to the database, we're going to create domain events, and we essentially accomplish the same thing that we were accomplishing with the triggers, but using a tool that sort of helps us look at the database without trying to figure out where all the triggers should go. And if you're using Oracle or another database, there are products like Oracle Golden Gate that can accomplish the same thing. Right? And Dependencies is slowly getting to the point where it supports support. And we can totally restructure, which means that we can turn a big ball of mud into more like, you know, a command model and a query model. And then as we eat the elephant, we can eventually build microservices around this. We may never be able to entirely unplug the big ball of mud, but it'll be a smaller ball of mud, hopefully. But if you are able to reach this point, you know, that's a pretty far leap. So it's going to take a lot of hard work and a lot of risk, but if you really need to get out of these legacy systems that are really difficult to work with, you know, well, you need to take that risk. So ultimately, you know, it would be good if after this refactoring, you can even do some reactive rework where you're using the machines efficiently, not just as microservices, but as reactive microservices. So if we can reach Reactive DDD, that's a great target. What I just want to show you is just run through very quickly this toolkit that we're developing for reactive architecture using DDD. It's a DDD-friendly toolkit called vlingo. It's based on actors. The large abstraction in the actor model, in our actor model, is called a world, and worlds have stages where actors can live and play, right? And vlingo actors are reactive. Vlingo actors can be designed around DDD kinds of components, like we have controllers, we have REST resources, we have aggregates, and these can be command-driven and producing domain events as using event sourcing or other approaches to just using CQRS even without event sourcing. And vlingo HTTP and lattice is how we vlingo lattice is how we distribute actor messaging across a large cluster. And vlingo streams is how we stream data from an event-sourced journal to other streams. So, you know, kind of think of an event journal with also the best of flat streams with any kind of element in it. And so what I actually want you to do is, you know, consider now Kevin Masteris and Alish is going to, they're going to make a presentation about some of the features in vlingo and what the programming environment is like. And they've been contributing to vlingo now for like 4 or 5 months, and they've been a huge help. They're Catalonian, right? They speak Catalan, so they're all, you know, you can all relate to them, and these are guys that are working with this stuff and making awesome things happen. So I want to give them the opportunity to speak now. Oh, yeah, I'll get that. Yeah, thank you.
I'm Alish. I'm gonna try. I mean, this component is meant to be boring. So it's like getting here, just set up something and start using actors. So it will be very fast to get into the actors. So yeah, let's try to start by the resource handlers. Nope. ¿Cuál estoy? Resource. Now, perfect. So, just one fast thing. You remember the world where all the actors live? So we require this constructor. But very fast, I'm gonna show you where you map everything. So remember that we try to be type safe. So mainly what we did is trying to be like the smallest thing as we can. So basically we map this post, get, and everything into the handler. So very, I think, or I hope, it's very easy to read. So everything handles to the method, to the class. So quite straightforward, right? So why we did this is because we want to focus on the domain. So everything else, which is infrastructure, we try to make it as smaller as we can, and we want to even do it even more smaller to just be very fast at the domain layer. So let's start with a register. This was seen by at the end. Hope so. Yeah, good enough. Well, I cannot. I just write it Linux. Sorry, I don't know how to use it. So basically, let's say you want to create some actor in the system, which is basically say want to just reset a user, which the user basically has the name data, like family name, and some contact data. Just fast there. Okay. So this is how we create an actor, right? So it's this information, which is okay. We create the user state, which is mainly where you create the actor, but then you use the stage. You see this here. Like, do you remember that you have the wall, but you have multiple stages where the actor can live on? So we use the default one. So just to put there and create an actor in that stage. So mainly, we say we need a user entity, which is the actor implementation, and then you have the user protocol. So it looks something like user interface with the implementation, and then you have the user state. Okay. It's a way to say we need a user entity, we give some parameters to the constructor mainly, and then we say create it. So done. And what we do is like return a response of created. That's it. Mainly it's like create the entity, put the actor in the stage, done. So let's move to, for example, that function. Yeah, here which is like, okay, we have the actor living in this stage. So it's as easy as say, hey stage, give me the actor. We have this address. It just does a factory say, okay, my actor have this address, find it. And when I have this the actor reference, which is like giving in the similar to return like you have this name of completable, well, future, which is something that we call completes, right? So we don't want to have this match between future, which is very known in Java. So we have this concept of completes, that something that completes in the future, right? So the actor says, when I give you the completes, then I call with name, which with name returns also complete. So it's like something that will return in the future as well. And basically we say, okay, we need something that is committed and is executed, then we return an actor for response, or if the actor is not found, otherwise we say actor not found, well, it's just not found, right? So it's like we try to put you very fast in the actors and don't try to put a lot of noise using HTTP, like mapping everything and using annotations. So that's one way what we found. And to share how to bootstrap your server. Okay. So this is what you need to bootstrap the server, right? So mainly you see the top of the wall, which is you need to create this wall to do all the actors right there, but then you create all the resources, like user resource, profile resource, passing the wall, and then you just say all the resources which are mainly the FTP mapping are like in the same group, and then you start the server here. Like server say with the resources, and that's everything you need to start. So it's quite like define things and start calling actors and nothing else. It's like it's way straightforward. And the main thing is if you like to start trying it using the actor system, this is a way to be very friendly with the HTTP. We all know how to call this, so it's a way to just bootstrap to the actors, which is the main goal, right? So it's not just being HTTP doing things very hard. So it's just go actors, try them, and play around. So I just wanted to do a very small presentation about the main thing, which is like resources, server, and handlers, and everything else is actors. So we're gonna see how actors play around more detail or more funny way now with Kevin. Well, yeah, it's fun. So this is boring, right? It will be very straightforward, just call actors. So that's the main goal. And we're gonna see another part, which is very more funny, how it works and how it delivers.
Yeah, thank you. So, who knows what is an actor actually? Who's already working with actors? So, an actor is actually a thread-safe object. And it's there in memory, and you don't need to block it. You get a message, you process that message in a transaction, and probably you send another message to another actor that will repeat this process. Yesterday I was talking with Vaughn about vlingo, because yesterday is when we knew that we were talking about the platform, and actually we talked, and I asked him what they showed, that vlingo is easy to use, or actually it's really performant. And he said, you need to show in 5 minutes both things. So I'm going to use an example application that we built for a demo. It's an event journal. Do you know what is an event journal? Who knows what an event journal is? Okay. So if you remember the slides, there was some arrows between events and objects. The event journal is that arrow. It's a wire that connects different objects. Okay? And those objects pull this journal to actually get events and do some logic. This is the arrow. So just to show the simplicity of, if I'm able to that. Okay. Those classes here are the actual implementation of an event journal, similar to Kafka, but simpler, of course. I counted them, and they are like 1, 2, 3, 6, 9, 12, 13 classes to implement something that's actually production ready. I'm not going to show all classes, just the main ones with some main logic. We know that really there is the adapter. Actually, this module has been written, the Fluent API has been written completely by Alex. It's an amazing work, to be honest. It's type safe and it's really cool. We have a journal that is only 25 lines of code. I think that's a microservice, no? Yeah. So what it's actually doing is just registering all that's happening on the event journal. It's just a list of events. And probably the most complex part is how to write them in disk. That is 200 lines of code there, 200 lines of code. It's using a write-ahead lock, and it's just writing on this appending on a file. Okay. And actually it's quite fast. It's the strategy that Kafka is doing. That's why Kafka is really fast. But I want to challenge that today. And do you know how many messages per second are your systems receiving right now? Do you have a number? Can't you say the number? No? So I'm working for a client that is handling on the spikes around 50, 60,000 messages per minute. It's not that much. You can have 100,000, 200,000. I'm not going to run a complete performance test because it will take more than 1 hour. And I don't have enough battery on my computer right now. So I'm going to just run it for 5 minutes. And we can check the performance number. Application is running. It's meter. Let's see that everything is online. Everything is green, fine. I'm going to name it power. So probably the number is really small. Actually, I cannot even see it from here. I will send a screenshot or something like that later. But right now we are processing in a single machine 200,000 messages per minute. This is the current flow. The average response time is 22 milliseconds. The deviation is 13 milliseconds. So the maximum response time of those number of requests was 50 milliseconds on a single machine. So that's actually the performance that you can get using the Acro model and using vlingo. There are other frameworks that are actually also really performant, but actually the numbers that we have are a bit surprising, because with a single machine you can get the performance actually is more performant than everything that we need on production for the 99% of business that we have in Barcelona. Then you will have more machines for availability and those kind of things. But in terms of performance, is enough. So this is a 97. Intel i7. It has 16 gigabytes of memory. It's a normal development machine.
And we're not even tuning. We're not tuning at all.
Right? No, it's not. It's the normal. And now it has 250 messages per minute. 200.
Can I ask you a question?
50,000.
While we wait, can I ask you a question?
Sure.
Okay, so how does this relate to ACA?
The difference between ACA?
Different similarities.
Or
how would you sell me this and not ACA, you know?
Actually, probably he will be better selling that. I'm not really good selling things. I've been working with pablie applications a lot. Play is built in ACA. And if I remember exactly now, I don't remember the exact number, to be honest. I need to check the metrics. But on a single machine, on an M5 large AWS instance, I think it's 8 gigabytes of memory and 2 cores or something like that. We are handling 1,000 requests per minute. I mean, of course, you have a PostgreSQL behind that. You don't have at this machine. Actually, Postgre is huge, so it's not a problem. We measure it. So I will say I don't have the numbers right now, but the performance in vlingo is a little bit better, just to say something. We can have an example later in ACA, doing something and check it. Implementing something like that takes 1 hour at least. Is there any other question? While we are waiting. Now it's almost 300,000. I'm going to just copy it. Just for the sake of time.
I'm going to share very fast. Before vlingo, I didn't have experience with any actor system, so I was struggling somehow when I tried to learn ACA, but having enough time to learn well. And vlingo was quite easy to start with. So it was it's a nice onboarding, at least for me. So I was able to learn something about actors and then implement something that uses actors later in non-blocking way, which was a challenge. Like implement an FTP API fluently non-blocking. So it takes a while, but I was able to. It's like to try and like start learning, and it's nice code. It found very easy to test, which is a very nice thing. So when doing unit testing, it comes and the complexity is very small, so it's very easy to do. So it was my experience. So if someone is looking for learning, is trying to play a lot little with the actors, give it a check. So that's my. It's not. I am not that good to do this, but you know, to try something. So that's what I share it.
You can answer that question about that.
Well,
Information.
well, you know, with all due respect to the light them folks, and, you know, I've written a book on Scala, right? I don't know if you know that. So I've got a fair amount of experience with it. My experience with who asked the question? Oh, here you go. My experience is that you know, I always found that using Akka with Java was not very nice. I think it's improved a bit over time, but it's it always seems like, you know, it doesn't really belong with Java, in my opinion. It's nicer to use with Scala. So if you are okay with bringing your corporate development ecosystem up to a language like Scala, and maybe it'll work well for you. But my ideas with vlingo is to preserve the investment that people have already made in Java over the years, and the fact that we're seeing a lot of great new features in Java that are over time going to largely catch up with Scala. I don't claim that it's going to have type system capability, and maybe you are you very functionally minded? Is that one of your motivations for? Do you use Scala? I assume you use Scala.
Yeah.
You do. So are you a functional programmer?
I'm trying to learn.
Yeah. So if your goal is to use functional programming, probably Scala is a better approach. But what I found too, my experience in being around the Scala community is the original message about Scala is that it's a hybrid language and that you can use OO and functional aspects together. But what I found over the past few years at least, that message has swung much more in the direction of functional programming, and that actually if you intend to use even a hybrid approach, where you use some OO features and some functional features, you're really not welcome in the community. They really just don't want you around because they're fully functional. And there are two kinds of Scala programmers. Those that are really happy that they never will have to program in Java again, and the other ones that are bitter because they can't program in Haskell. and it's mostly the second group that has emerged. So, you can take that for what it's worth. But I'm not actually trying to compete right now in a functional environment. But we'll see how functional turns out, right? But I know some companies that have put a lot of investment in F#, and I also know that F# has faltered. Again, it doesn't have maybe the type system that Haskell provides, or even that OCaml provides, as I understand it. But you know, we'll see. I don't really see the functional community growing, and I think part of the problem is the basic message that most of us aren't welcome there. You know, we just aren't mathematicians. So just, you know, that's my experience. And so, if, you know, if you don't know category theory, and we'll see how it goes.
Actually, I have another question relating to functional programming. Do you think it's possible to use DDD with functional programming? Because
absolutely, yeah.
The thing is, you said about the Anemic domain model. So in pure functional programming, you have the concept of the IDTs, which are basically that, Anemic. So you don't have any methods inside the data classes, right?
You can use records or structs, whatever your concept is, to, you know, that you're using, and pass the data to functions, basically, right? And so you can still develop a ubiquitous language. Again, I'm not saying that functional is, certainly functional is possible, but again, the attitude toward even DDD with the functional language is we only process data, right? And the names of the data and, you know, the fluency of the functions that you use, it's really not important to most functional programmers because they're thinking, you know, with math expressions, and they're thinking about map and fold and things like that more than they're thinking about what the business actually thinks about. So, you know, see how it goes. Yep.
Before I forget, there's a contributor actually made vlingo run on Android. You can run vlingo on Android. I think that's pretty cool. And there are also some examples in Kotlin. So there's people that actually don't like Java. You can try to use Kotlin also if you like it. Yeah. I think that's what
and since you were brave enough to ask me a question about that, which book would you like?
The green one. I already have the red one.
You have? You want this one?
Yeah.
Okay. There you go. And I have another book. If someone dare ask me a question. Anybody not have this book? Okay. Ask me a question. Somebody.
I'll ask you a question.
Okay.
Regarding the functional programming as well. So you talk about that we can incorporate the process, the concept into our language into the ubiquitous language.
Yep.
Do you think that the functional programming concepts can belong in the ubiquitous language? Like this is a function, this is a monolith.
Yeah, yes, I think so. And I think that there needs to be more education around that. And I think actually a really important message. I think a really important message, though, is to tell people that they, you know, they don't have to know category theory, and they don't have to know. There's a lot of good to be gained out of functional programming, and I'm not opposed to it. I'm just opposed to most of the attitudes about it.
Yeah, sure.
That's all.
And I can agree. But doesn't that clash with the concept of that we have this language and we share it with the product manager, and I mean it's not just for the developers. So it's meant to be a communication tool with other parts of the company, and not just with the developers. We can't go to the product manager and talk about functions.
A ubiquitous language lives within a bounded context, and a bounded context is owned by one team. So sometimes the word ubiquitous can make people's mind think that it has to, you know, sort of permeate every, you know, nook and cranny of an enterprise, and it doesn't. It's really meant to have strict meaning and behavior within a boundary to a single team. Outside that boundary, you know, any other team can speak whatever language they have. And so but I'm not even quite clear why you are concerned, like if a function has a meaningful name and has a business-related name, why would anybody have trouble?
Well, it's most about like more abstract parts of this. This is a functor, this is a monad.
Yes, exactly, and that's what I think. When those concepts tend to be the things that surface and are discussed, you just scare most people away, right? And then, I'm sorry, but the attitudes that go with that is you don't deserve to be working with us if you don't know category theory, and heaven forbid you even say the word set theory or set. That just doesn't even carry water anymore, because that was proved wrong, 100 years ago and stuff like that. It's like, wait a minute, why? Oh, because ultimately, if set theory were true, that would mean that you could have a set of all sets. And since you can't have a set of all sets, we can't reason about that anymore. So let's use category theory instead. And then when you say, well, category theory has a lot of overlapping concepts with set theory. In fact, they even talk about the category of sets. Isn't that interesting, right? And then you start to have conversations about that, and then there's another detour that says, oh, wait a minute. Yeah, really, category theory isn't all there is to it. There's this other theory that, and I can't even remember now because it tires me. Really, it's a moving target. So basically what it is a message that says, you don't belong with us, you don't have a PhD in mathematics, so just sort of go do your object thing and whatever you call it. We'll be the smart people. I mean, seriously. So, anyway, I hate to, but if you love the stuff and you're happy with it, enjoy it. I think it has limited value in a real business environment. Anyway, enough on that. But I've got some T-shirts, and if you'd like a T-shirt, we've got some other swag, got some stickers and stuff. So if you'd like that, anybody would like to have a IDD workshop T-shirt? Yeah. Well, yeah. Okay, and I got 2 vlingo T-shirts, 2 larges. There you go. And come and get a sticker or a pin or something afterwards. But any other questions? Yes.
Yes, I would like to ask, what can I add to my software development process on top of DDD to make software making cheaper?
Yeah, really big part of it is. Are you testing already?
Yes.
Okay. Are you using event storming?
Depends on the client.
Yeah. So event storming can really accelerate your learning, right? So software is about learning. Software is about emotion, right? Software is about feeling good about your understanding of things or your ability to understand, right? And so the quicker you can learn, the cheaper it is. Yeah.
Thank you.
Yes.
How would you sell DDD to a company that doesn't know anything about it? I mean, my company doesn't know anything about it. Who are people
I've been saying this for a long time. Even before my Red Book was published almost 6 years ago now. But what I say is, don't even use DDD. Don't tell anybody that you're using DDD. Just use the tools, right? Just say, let's have conversation. Let's learn together. Let's explore, how we could make this more strategically viable or even great, right? I mean, what I do is I tell people, how would you like to give people the feeling that they have when they receive a box that has a MacBook Pro in it, right? How many here have a MacBook or something? Mac users? Yeah. So you got your hand up there, you're convenient. How did you feel when you had that Macintosh box in your hand?
Like really interesting. You have something that always works.
Yeah. What about the box? Yeah. I mean the container. And you look at the box and you're certain that you hear something singing, you know, and you're kind of even like, should I even break the shrink wrap and open the box? And when you finally convince yourself that you can, and you get the Macintosh in your hand. I'm really making Kevin angry right now. But, you know, it's an experience that people share, that this is an amazing product, right? And it's too bad that it's not quite maybe as amazing as it used to be. But what if you could do that with your software? What I'm trying to say is, imagine you can do that with your software, where someone just like says, I have confidence that this software is going to help me get my job done, and they don't hate it, you know. They not only don't hate it, but they long to have yet another good experience with it, and it's such a nice product. It's like seeing that box with a Macintosh in it. Just ask people, do you want that, or do you want, you know, the big ball of mud over and over again? And it's not easy. I'm not saying it's easy to. Was creating the Mac easy? Was designing the Mac easy? Was, you know, was working with Steve Jobs easy? So, yeah.
What would make you decide that you want to use event sourcing in the system?
Yeah, there is a particular use case for event sourcing, which is pretty much, you know, I need an audit log for every thing that's happened in my model. You know, we need to know, and there are some businesses that have kind of the requirement, you know, maybe the government or some regulatory agency requires you to keep track of that. Maybe it's financial dealings, stock trading, banking, whatever. It can be useful for that. And you know, what I would say though, just be careful not to use it because it's cool. You know, it's new and exciting, and you just want to try it out. You know, what I would say is, at first glance, and as you're first using event sourcing, it's way easier to use than OR mapping, right? But is that a compelling reason to use it? Could you gain other benefits? Is having a discrete, you know, sort of nugget of factual understanding that this happened at some point in time, and all these millions or billions of things happened over time, is that valuable to your company? Like, can they you know, have more accurate analytics because of it? Can they, you know, can they experiment with it with, you know, what if this had happened instead? What if, you know, and play through different business scenarios like that. You know, the value is there.
For you, it is only the event log, not the ability to scale either, just because you can write in a
yeah, but that's a really technical motivation, and I'm not saying that isn't a good reason to use event sourcing, but I would say make sure that the business agrees that you have, you know, that you can rationalize using event sourcing purely for a throughput, you know, kind of requirement. I mean, I you know, maybe you do, but there are business cases for using it, and others that aren't as strong.
Always has to be a business case to use it.
Well, yeah. Well, I think, yeah, but that's not how it's been used, right? It's been used a lot because it's cool, and people then end up not using it in the correct places, and then the company gets stuck with this, and they move on because they now have event sourcing on their resume. Yeah. Yep.
If I am already using DDD in my job with Java or Kotlin, and I like to start working with actors, which do you think is the best way to start? I guess vlingo is already little early to start working with.
Yeah, just go to docs.vlingo.io. And we're not real strong right now on documentation, but there's some really brief chapters and tutorials on using it, and I think you can jump right in. And Kotlin, it works with Kotlin. So Abel Fernandez, yeah, maybe you know him. He's already working with it on Android. Kotlin, vlingo on Android.
But maybe for production, it's ready to use, or
so I'm cautiously optimistic about that. What I say is that the parts that have been under development for a year or so are quite strong, and I think they are production capable. But we have a very conservative versioning right now. I think we're at version 0.7.4 or something like that. I think some of those components could be probably at 0.9 something. But we're just, we know that people are going to adopt this, and they are. So I know of projects happening right now. We're using it, and they're having success with it. So yeah, I think there are parts of it that are ready for production, but we'd like to also just give people more choice in what they use, and we want to. Some people who have less strength in programming have said it may be way easier than Akka and Scala, but it's not that easy for me, right? And instead of us being like the, other communities and saying, then you don't belong with us, we say, then we aren't good enough yet. And we're going to make it easier for you, simpler, not necessarily easy, right, but simpler for you. And so our goal is to make vlingo, capable of being everything that it is now, very great throughput, 3 million messages per second through an actor, and that's like a slow mailbox. And but we just want to make the experience better for any developer. I don't even want to grade the developer as to say, we just want to make it great for everyone, and that's our goal. Fluency, simple use. So try it out, and if you find something difficult to use, let us know. Yeah. Right. Okay. Yeah. Yes.
I quite like the section of your presentation that presented some tactics for dealing with legacy, and I was wondering if you had any recommendations for further reading, or if anyone's collected some case studies or anything around gathering those tactics together or anything like that. Well,
so you'll probably find some of that material around Dependencies, right. And it's an open source project. Not that, and let me warn you too that there is also potentially misuse of Dependencies. So some people are saying, what I'm going to do is tail my transaction log, and I'm going to generate all my events, even in a new bounded context, right? In a new microservice, I'm going to generate all my domain events from the tail log tailing, right? Bad idea. It's not explicit, it's implicit. You can't see that happening. Don't use it in that way. But if you have an integrate or a legacy problem to solve, it's a practical tool. And Golden Gate, Oracle created this kind of thing that sort of validates the idea, I think.
Okay.
Yeah, so I would look there. I would look under Golden Gate documentation, Dependencies. Currently, I don't know if he's the chief architect of Red Hat, but Christian Posta, maybe you've heard of Christian. He's a contributor to Dependencies, and I think he's got probably a lot of good tales to tell about that. Yeah. So if you look up Christian Posta on Twitter and hit him with a direct message or something, we'll probably get some good information. Thanks. Other things?
Getting back to event sourcing, you mentioned the accountability feature of it, like
the what feature?
Accountability, like it may be useful for regulations or laws, don't you think it also has like a design, some design advantages, like to focus the design in a different way?
So maybe like if I have an aggregate or some kind of entity that is an event source, I can maybe reshape, refactor the
flow, yeah, the general application flow, yeah.
Oh, the flow. So like I persist some events in my journal, and from that, yeah, sure. The only thing I would say is when you use event sourcing, you have to have an event for every kind of change to the event sourced aggregates. And some of those will neither be interesting or even, useful, or maybe not even secure to disclose to outside, to outside your bounded context. So, so just be careful that you filter out those that are, sort of fall into that area. But that also, I think, says that, if you design really, a good model around your business and the more, business interesting or important events that you can model, the better. And that will show up if you're using event sourcing, say, with the motivation for it being a strong case for the business to use and not just technical, right? Because yes.
Well, there is a lot of resources about scaling microservices. Right now it's like not a silver bullet, but it's a go-to solution for a lot of problems.
Mm-hmm.
But I think it's not enough spoken about scaling the data along with them.
And it's not
scaling
enough.
the databases, because, for example, if each microservice has the data, how do you manage this kind of complexity?
Well, I mean, okay. First of all, in my experience, there are very few companies, projects, whatever, that need the kind of scalability that a lot of people say that I should just say that a lot of people talk about. Okay? So I usually survey every single workshop for how many transactions per second do you deal with, and most are in the 100 range or less, and some are in the upper hundreds to maybe a few thousand. Very few are anywhere in the 10,000 range, maybe 1 or 2% of all students. There were none in my class this week. And so, like, I would say it's something like 97% or greater of all software projects in the world don't need that. And Kevin just asked how many here are processing. What was the question? 200?
100,000.
Yeah, 100,000 requests per second. So, I mean, Kevin saw numbers a week or two ago up in about, when he runs this over time and everything gets warmed up, I mean, even 280,000 per second. So and that's on a single node, right? So load balance that and put 9 nodes out there, or 5 nodes, and I don't think you can find maybe a few thousand companies that need that, or even systems that need that. So I just say, yeah, it's all interesting to talk about, but we want to write software that is way more scalable and higher throughput than anybody needs, just so we can confidently say, to me it's more important to say, take that 50 node cluster down to 5 nodes, save money. And unfortunately, I hear arguments like, Yeah, but nobody's worried about that. CIOs are just spending millions of dollars a year just to get on AWS, and they're just pushing all this really poorly performing, inefficient software out there, and they really don't care because they just want out of the data center. But, there were actually 3 slides that I took out of my talk tonight where Dave Farley, maybe you've heard of Dave Farley, right? Continuous delivery, where, he tweeted maybe like a month ago and said, do you know that he said, I can't think of any other business operation in the world where we are willing to accept a 50% decrease in efficiency for ease of use, except for the software industry. So now, take those 50 nodes and cut it down to 5 nodes, even if no CIO, for whatever reason, cares about that. If it takes 1 more second to do something that you could do in 1 second less with simple, easy to accomplish efficiency, what that actually spells is you are generating more CO2, right, carbon dioxide, into the atmosphere than if you didn't, 1,000 times more. Now, think of how many seconds and CO2, elements that you could not cast into the atmosphere if you cut these 50 or 100 node clusters down to 5 or 7 or something like that, right? With more efficient. That's something, that I'm after. Okay. Okay. Well, thanks for attending. Thanks. Get some swag if you didn't get a T-shirt or something. Yeah. Thanks for attending. Enjoy some beer.